An interesting estimate can be made for the proton lifetime from the fact we live lifetimes of the order of a century. The human body contains about 10 to the 29th protons, and if a proton decayed, it would release nearly 10 to the 9th eV of energy, enough to destroy thousands or millions of molecules. If a proton has lifetime T, and a gram of matter has about 10 to the 23rd protons, the energy released per year is about 10 to the 23rd times 10 to the 3rd MeV grams inverse over T. With 1 radiation equals 6 times 10 to the 7th MeV grams inverse, the total dose is about 10 to the 18th over T rad. This had better be less than about 100 radiation, or most people would die young. That gives T is greater than, or equal to about 10 to the 16th years, compared with the lifetime of the universe of 13.8 billion years. Experiments have been underway to improve our estimates since about 1982, and so far there is no evidence for proton decay. When careful calculations are carried out for the simplest SU5 grand unified model, it predicts a lifetime of about 10 to the 30th years, and that is now excluded by experiment. Supersymmetric guts tend to predict longer lifetimes, 10 to the 33rd or more years, and are at present not inconsistent with the data. Currently, there are limits for over 20 different proton decay modes, the strongest of which implies a lifetime of about 10 to the 34th years. Detector upgrades will search for another order of magnitude in the coming years. Eventually, experiments will be sensitive to a lifetime of well over 10 to the 34th years, either finding a signal or setting limits.